so let's start talking about inverses. So what's the inverse of a line? Another line, right? And we've learned before that all we have to do is transpose the points. Correct? So if I have 0, 1, then it's going to be 1, 0. Let's pick another point. Let's see. How about 4 looks like 9? Then it would be 9, 4. 1, 2, 3, 4. Remember that? And then we draw ourselves a line. And I'm just going to do a rough line. Okay, that is pretty good, huh? All right, a quadratic function. What is the inverse of a quadratic function? A square root function, right? The inverse of a square is a square root. So also, let's see, this is up 1, 2, 3, 0. So it would be, 0, 3, so it would be 3, 0. And then 1, 1, correct? And then what's my next magic number? 4, 2, right? Instead of 2, 4, 2 squared is 4, so the square root of 4 is 2. So 1, 2, 3, 4, up 2. So we did that function. Then we have a cubic function. What's the inverse of a cubic? A cube root, right? So if this one's up 1, 2, 3, I'm going to go out 1, 2, 3. What are my magic numbers for a cubed root? 1, 1, and 8, 2. Good. 1, 2, 3, 4, 5, 6, 7, 8, up 2. Goes down. We'll just... So now we come to our exponential function. So guess what the inverse of an exponential function is? A logarithmic, right? So that's where we're going. Logarithms are inverses of exponents, or exponential functions. Okay. So 0, 1. So I'm going to go over here, and I have another. That was our reference point that we used for almost every single one of our exponential functions, right? 0, 1. So logs are going to be 1, 0. And then my next point on this one looks like it went over 1 up 2. That would make a base of 2. So this one's going to be over 2 up 1, over 2 up 1. So basically it looks like it's not considered decay. It's considered a logarithmic. It's not growth or decay. Okay? So let's notice some things about exponential functions. So exponential functions, first of all, right, if they have, no matter what the base is, when x is 0, it's always 1. We're going to see the same type of thing with the logarithmic. Also, the numbers can't be less than 0, right? Y always has to be greater than 0. Well, what do you notice on this one? What has to be? X has to be greater than 0. Make sense? So on this one, y has to be greater than 0, right? It's never going to hit 0. But on this one, x always has to be greater than 0. So it's just the inverse. Yes?
And that's always the graph, right? Or is that like a little log? Like it has to be
Yes.
Is it
Yeah. Okay. So, and we're not going to manipulate, we're not going to do transformations with logarithms. That's what you'll start doing in math analysis. But you'll already be ready for it, right? Because you already know what transformations work, how transformations work, right? The x moves along the x-axis, and whatever's with y will move along the y-axis. Okay. So, we're going to start basic. I'm going to see if you can figure out the pattern. I want a pretty... That one's 3. Got it? What am I doing? I'm solving for a box is what I'm doing, right? Right? Talking exponent. I'm answering what the exponent has to be to make 32. What's the exponent have to be to make 2? What's the exponent have to be 16? Do you see how we did that? 2 to the 4th is 16. 2 cubed is 8. 2 to the 1 is 2. 2 to the 5th is 32. Good so far? Thumbs up, thumbs down. Okay. All right, what this one? Good. Right? 2 to the negative 1 is a half. One half. So 9 to the 1 half equals the square root of 9, which equals 3. Are we good? That one's hard, huh? One half. Because 2 to the 1 half, we can rewrite that as the root 2. You guys are good. He's seeing it faster than I am. The 4th? It's got to be negative because it turned into a fraction, right? The exponent has to be negative in order for it to turn into a fraction. And it went from 2 to 16, so it's negative 4. Okay, we ready? Okay, that was a little bit more challenging. So what about this one? 2 to the anything to the 0 is 1, right? No, that isn't it. Yeah. About that one. So are you noticing something here? All right. Okay. It's not homework. I don't even think we need to do these. We flew by them, right? Okay. Well, I did the thumbs up thing. Yeah. And a few key people I noticed had thumbs up. So, all right. So what you've been doing right now is you've been evaluating logarithms. Okay, I'm just going to show you how it's written. So, logarithms are exponents. This is the same thing as this. This is a base. This is a base of 2. This is a base of an exponent, right? So this is where our base goes. Our base goes below where the log is. Okay? So logarithms are equal to exponents. The number I've been putting over here this whole time is the exponent, right? That's what you guys were solving for. You guys were telling me that 2 cubed is 8. So we're just going to start rewriting it. 2 cubed equals 8. Logs are exponents. They're the inverse of exponents, okay? Exactly. It's just in a different form, okay? You guys were evaluating this, right? You guys were telling me what exponent is going to make 8. This is doing the same thing. What exponent is going to make 8? Same thing over here. 5 to the what makes 25? 5 squared makes 25. King. You're going to see this normally. Yes. Well, you're going to see it. Yes. Okay? All right. So this is very important. This log base 5, right, is just like writing this. Okay? We'll get there. Okay? So all we're doing today is kind of evaluating. All right. So 2 to the what makes 8? 3. 1/5 to the what makes 1/25. They didn't change. It's still a fraction, so you don't have to worry about negative exponents. So 1/5 to the what makes 1/25? 2. Right? If you take 1/5 and you square it, you're going to get 1/25. A fraction to a fraction doesn't need a negative exponent. A number to a fraction does. A fraction to a number does. But if they're both fractions, it doesn't need a negative exponent. Yes. You could.
You would accept either one.
Can you make it into a negative exponent? No, because you'd have to change the base and change. Don't do that. Don't do that. Okay? We're going to be manipulating exponents, so you're not going to want to do something. Oh, look it. 3 to the what makes 81? 4 to the what makes 1/2? Now we went from this turned into a fraction. Negative 1/2. Because we had to make it into a radical, and it switched from a number into a fraction. Okay, this last one. This is called, hold on, this is called a natural log. Natural logs are used with E. Okay, we'll get there. And I'm not even sure why I'm exposing it to you right now. But this basically has an invisible E right here. Whenever you see ln, it's got an invisible base of an E. Okay? So E to the what makes E squared? E to the what makes E squared? 2. All right, this is one of the most important properties right here, guys. Anything with these two numbers match, it's always going to be equal to this. Does that make sense? Because E to the what makes E squared. So it's almost like when you see E to the E, you can just cancel it and the answer is 2. Here's another example. I might have this in the next slide. I just don't. Two to the what makes 2 to the 4th? 4. You see that? How you see the base and the number, they kind of cancel each other out? You see it? Okay. All right. Kai, I need you sitting up, please. All right, so you guys go ahead and do these on your desks really quick, right? And then we'll fill in the numbers. 59. We're going to spend about 5 minutes on this. I'm going to pause it. It takes the fun away. Why? Because I'm unveiling it? Okay, so 2 to the 4 makes 16. 4 to the 1 makes 4. 6 squared makes 36. 6 to the 0 makes 1. 1/4 squared is 1/16. 1/3 cubed is 1/27. 36 to the 1/2 is 6. Anytime a number goes smaller, it's a fraction, right? Because 36 to the 1/2 is equal to root 36, which is equal to 6. Okay? 27 to the what makes 3? 1/3. It went smaller. It must be a fraction. 4 to the what makes 164? It went to a fraction, so it must be negative. And 4 cubed is 64, so it's -3. Are we good? So these are tougher, right? Remember I told you light bulbs are going to go on at different times for people. These are a little bit tougher. Okay? I'm going to say it again. 4 to the what makes 164? Well, 4, I need the talking to stop, please. 4 cubed would make 64, right? But I want to turn it into a fraction, and we use negative exponents to turn into fractions. Make sense? Okay. All right, and 5 to the what makes 125? -2. We better? Thumbs up, thumbs down. How are we doing? Okay, I've got a couple sideways. We're not going to go very fast. Do you want more? Okay, do these. We're not done teaching the lesson, though. I just need you guys to get solid in this. Okay? You guys are doing fantastic. 3 minutes. Not much further. Lama, is it better than last year? Yeah? You coming up with properties? That is this is a base of E. Base of E. And whenever you don't see here, it's always a base of 10. No. 4 to the what makes 16? You, 4 to the what makes 16? It's getting bigger. I'm not understanding what you're saying. Just ask yourself, 4, if you ever get stuck, to 4 to the what makes 16?
Always do this number.
No. This right here is this. Exactly. Yep. One more minute? Chris, I thought we already had a discussion. Got it. Yes. E is a number. That's negative exponent. But it's getting smaller, so that's negative and a fraction. you ready? Sometimes it makes your brain hurt a little bit, right? Okay, let's go over them. Am I still recording? I am. Okay. So 3 to the what makes 81? 3 to the 4. 4 to the what makes 16? 2. 7 to the what makes 149? Negative 2. Correct? It got bigger, but it turned into a fraction, right? So negative exponents are positive fractions. Okay, 32 to the what makes 2? 4. It's 5. Thank you. Nate feels so proud of himself. 9 to the what makes 3? 1/2. 2 to the what makes 64? Negative 6? Is that right? 4 times 4 times 4? Yep. So 16 to the what makes 1/4? Negative 1/2? Right? Because to get from a 16 to a 4, you're going to need a square root, which is a fraction, which is a fractional exponent, and then we're going to turn it into a fraction, so we need a negative sign. Those are harder, right? It's okay if you're not like, oh yeah, got that one easily, right? You got to think about it, okay? All right, 2 to the what makes 1/4? So it had to get bigger, so we need a 2, but then we turned it into a fraction, so it needs to be a negative 2. E to the what makes 3? 3. E to the what makes 5? E to the what makes e to the 5th? 5. All right, I'm going to move on. Okay? Yes. 15? 17. Okay. 16. I need to turn, let's rewrite it like this. 16 to the what makes a 4th? Well, in order to make 16 into a fraction, we need this to be a negative exponent, right? And then for 16 to get smaller, to get from 16 to a 4th, you'd have to take the square root of 16, which is really 1/2. Right? These two things are equivalent. A fraction, you can write it as a fractional exponent, or we can make it as a radical. They're the same. So that makes this negative sign a 1/2. Okay? They're going to be tougher. Okay? Eventually, it'll click. Okay? All right, moving on. So we've got some properties. So whenever you think of logarithmic properties, think of properties of exponents. So let's review. You guys tell me some properties of exponents? Negative, okay. So anything to a negative power makes a fraction, true. Okay, so if I have the bases are the same, so if I have x cubed and x to the 4th, what do? I add them, right? When I have bases the same, I add them. What else? Okay, so I can, when I have bases are the same, when bases are the same, the exponents are equal. We're going to definitely use that. What about this one? What do we do with that? You multiply them, right? Power to a power. Or isn't that really this? Isn't that 4 times 4 of these? Isn't that true? Yeah. Isn't it 4 of them? I shouldn't write it like that. It's not 4 times it, but it's 4 of them. Does it make sense? So I'm going to put multiplying. It's 4 of them. I should put multiplication like this. And there's another one that we're going to use. What about this? X to the 4th over x squared. What do we normally do with that? What we're really doing is we're canceling out. Well, isn't canceling subtracting some away? So it's really x to the 4 minus 2. All right. So remember that. When we see division, we subtract. When we see power to a power, it's multiplying, right? When we see common bases or multiplication, we add the exponents. So we're going to use all those same rules with logs. This one, negative exponents make positive fractions. We learned that, right? We've just used all of those a lot, correct? Okay. So we're calling this the B box. Yes, fractional exponents. So here we go. So b to the what makes 1. We already talked about this. 0. There's one of our properties. I'm just going to do our properties over here. So b to the 0 makes 1. That's our first property. I don't think we're going to use all of them today. And this one I already talked about too, right? B to the what makes b? 1. So whenever I see this, I can just kind of basically this is to the 1, right? To the 1 power? So I can kind of just cancel it. This isn't b to the 0 makes 1, right? So whenever I see a 1 here, I know this number has to be 0, correct? And whenever I see these match, I know that whatever the exponent is my answer. Let's practice it. What do I have on the next one? Let's practice it. Let's say log 3 to the 3 to the x equals what? X. Log 4 to the 4 to the 10 equals what? You guys got this? Okay. Log 1,000 to the 1 equals what? The only way I can get a 1 is by applying a 0 exponent. Okay? Are we good? I don't think I want to go any further than that. So let's see here. I think I'll do this tomorrow. I want to show you why this works. You still have homework. Okay, so let me explain the homework and then I'm going to give it to you and let you guys work on it. So for the first 9 problems, what you want to do, it says, write the given exponential equation in logarithmic form. So all you're doing is writing it in log form. Bryce, put that away, please. So to rewrite this, I'm going to write it log. Whoops. Log with a base of 5, right? Parenthesis 125 is equal to 3. 5 to the what equals 125, right? That's what we're writing. I'm going to write it over here. Log base exponent equals a number. Make sense? That's what you do with all of these. 1 through 9, you're going to change it into this form. You know this is your base, this is your exponent. You're just rearranging it. We're just rewriting it. I'm going to do this one. So I'm going to write my base of my base is 3. So log base 3, and I write my equal sign. This is my exponent, so my exponent goes here. Parentheses 27. 3 to cubed is 27. And I always go back and make sure I did it right. 5 cubed is 125. Yes?
What is the benefit, right?
Because we're going to use properties of logs to solve exponents. We're going to get there tomorrow. Okay? You want to preview real super quick? So if I have something like this, if I have 3 to the x equals 27. 3 to the what makes 27? 3, right? What if I have this? 3 to the what makes 28? Right? You don't know. Make sense? We're going to use logarithms to solve exponents. Okay? All right. I'm running out of time. These, we're going to switch it. We're going to go from logarithmic to exponential. So I'm going to take the exponent, right? This is the base. This is the exponent. These are much easier to write. It's much easier to go log to exponential than exponential to log. So I'm just going to write my base, which is 6. My exponent is 4, and it equals 1296. Yeah, the answers, we're just rewriting them. No, it's not it. I'm almost done. Almost done. Hold on. Guys, these are the harder ones right here. This is, okay, ready? So I'm going to rewrite it. 9, right, is my base. My exponent is here, equals x. So what does x equal? Yes. We're solving for x. Here's another one. Here's a little bit harder. It looks complicated, right? It's not complicated. 10 is my base. Here's my exponent, equals x squared plus 1. Subtract the 1 from both sides, and I get 9 equals x squared. So x must equal 3. Why does x not equal negative 3?
Because that is doing fraction, that is doing math.
10 to the 1 is just 10. And then you subtract 1 from both sides. Why can't x be negative 3? Nick? Well, let's go back to it. If x squared was if this was negative 3, it goes back to this, right, the graph. X can't be a negative number, right? It's got to be a positive number. Okay, I'm going to pass out the homework. Sorry, it's a compact day, but I think we're doing good. Thumbs up. We're okay. You subtract 1. Mm-hmm. Those are E's. I'll show you. Yeah, give me a second. I want to show you guys really quick these last ones. Here's an extra. Yeah, give me a second. Okay, so this one. Remember, this has a base of E. So this one is basically E has a base of E. ln always has its natural log. It has a base of E. So it's E to the 1 equals x plus 1. So x equals E minus 1. That's all you can do.
The model, or even, will we talk about what E is?
Yes.
Okay.
I won't change it. Yeah. You're just solving for x. Awesome. Okay, so Mr. Miramontes called this log Benet, is the cousin to, what is that? Log Benet is the cousin to Ben. B to the exponent equals Ben and log Benet. It is supposed to be funny. I thought it was funny. Ben's cousin is log Benet. Hey, you'll remember it, right? Okay.